Hello everyone. Today I'll have a presentation for our deep learning project, movie reviews classification based on BERT with fine-tuning. And let's have a short introduction. 2018 was a year of major breakthroughs and advances in NLP, especially Allen AI's Elmo, OpenAI's OpenGPT, and Google's BERT all achieved very good results in a number of tasks. Among them, BERT as a pre-trained language representation model obtained state-of-the-art results in 11 NLP tasks, which is very impressive. Therefore, in this report, we aim to use the BERT model and add an on-chain neural layer at the end of the model to obtain a better text classifier. In our project, we choose a dataset on film reviews that can be used to train a sentiment classification model to enable sentiment analysis of film reviews. And before building the model, we need to process the text dataset. Here we take Cola dataset as an example to display the process because it can be seen a more difficult task than sentiment analysis. Step 1. Call the GPU and install Hugging Face library, the most powerful BERT architecture that can support different pre-trained models. Step 2. Load the dataset and parse the text data briefly. Use pandas to preview the raw text data as shown on the left. After which, focus on the sentence and tag fields, where 0 means grammatically unacceptable and 1 means grammatically acceptable. The figure on the right shows 5 examples of grammatically unacceptable. Next, the sentiments and tag fields are loaded into the NumPy array to obtain the results shown in the green box. The third step is to pre-process the data. We want to use BERT to classify the text data. So we need to process the data first to make it meet the requirements of BERT for the data. First, we use tokenize encode function. Tokenize and convert tokens to IDs to complete the text data separation and the requirement of turning the separated text data into lowercase words. After that, the processed data is formatted. The specific steps are as follows. First, adding special symbols at the beginning and end of sentences. Then padding or truncating sentences so that each sentence maintains a fixed length. Using attention masking to distinguish padded from non-padded tokens. Through the above steps, it is found that the maximum length of text data is 45. So we set max length to 64 and divide the obtained new dataset into training set and a validation set according to the ratio of 9:1. Then we train our classification model. In this task, we first need to change the pre-trained BERT model into a classification model. Hugging Face's PyTorch implementation contains a series of interfaces designed for different NLP tasks. We will use BERT for sequence classification, which consists of a normal BERT model and a single-line classification layer, which is mainly responsible for text classification. After loading the model, the next step is to tune the hyperparameters. We initialize an AdamW optimizer for the loaded model. The hyperparameters are chosen as follows. The batch size is 32, and the epoch is 4. Later we will see it is probably too many. Next, enter the training loop. Prepare the input data and copy it to the GPU. And before calculating the gradient each time, you need to clear it to 0 because the gradient of PyTorch is additive. Next is forward propagation. Loss and lodges will be returned. Accumulate loss and do back propagation with gradient clipping. Update parameters and learning rate. Then we monitor the training process. After completing an epoch training, validate the performance of the model. Set the model to evaluation mode. Accumulate the validation loss and calculate the accuracy of this epoch. And also measure how long the validation run took. The training results are as follows. As we can see, the validation accuracy remains contained at 0.82 across all 4 epochs, where the training loss increased slightly from 0.08 to 0.11, which indicates that the model is performing consistently well on the validation set. Then we load the test set and evaluate model performance using the MCC to evaluate test set performance due to the uneven distribution of the categories. The steps for processing the test data are the same for the training dataset. Then we can apply our fine-tuned model to generate predictions on the test data. Calculate the MCC for each batch. Combine the result for all batches to calculate the final MCC score. The final MCC score of 0.497 indicates good performance on the dataset. In the end, using this dataset as an example, we show how to use PyTorch and the transformer libraries to implement model training and evaluation. Without any hyperparameter tuning, we obtain a good MCC score. This shows that using pre-trained BERT models can be effectively in improving the performance of NLP tasks. That's all. Thank you for listening.